All right, let's try now a couple of compositions of trig functions. This is the basics. So you should know before you do this inverses. So you should know, let me write it down here. For example, the cosine of an angle equals a ratio. In the cosine case, that's adjacent over hypotenuse. That's the angle. And the inverse, you would switch the x and the y values. So the cosine inverse of the ratio, still the same ratio, adjacent over hypotenuse, is equal to this theta, which is the angle. Okay, so you need to be very careful when you're doing these compositions because, and I forgot to write the inverse on all of these here, okay? We're mixing regular trig functions with their inverses. And not only that, but the ratios are changing depending on what function you have. For sine, if you see a sine, ratios anywhere for the answer or for the input to the answer will be opposite over hypotenuse. For cosine, it will always be adjacent over hypotenuse and tangent opposite over adjacent, etc. So here's how we approach these problems. We're working the inside of the parentheses out. So just look at this part right now. We're just going to look at the inside of the function right here. So we're going to do the sine inverse of negative root 2 over 2. So one thing you should be aware of with is your special rights as well. And when you see negative root 2 over 2, that's the same thing as negative 1 over root 2. Okay, so you just have to be aware of that with your special right triangle. So let's draw a circle. Not a very nice circle, sorry about that. Let's see if I can draw a better one. There you go. That looks good. So for sine inverse is restricted either from 0 going this way on quadrant 1 or 0 going backwards into quadrant 4. That's a negative rotation and that's a positive rotation. And in addition to that, all of the ratios here are positive and all of the ratios here are negative. That just happens to be a coincidence, okay? There's ratio, positive and negatives depending on the quadrant, 1, 2, 3, or 4, and this rotation thing is just happening to be what direction we're going around the circle, okay? So quadrant 1 or 4 is the restriction for sine inverse. You should have watched the sine inverse video before you look at this. Okay, so let's draw this since this is a negative ratio. Let's draw a triangle in the negative ratio quadrant, not the negative direction necessarily. That just happens to be a rotation thing, okay? Negative ratio quadrant right here. You're going to have some angle here, and this thing is going to be your opposite of the ratio. That's going to be your hypotenuse. So write them down. You have a negative 1. And the radius is always positive. Okay, and hopefully you're recognizing this so that we see that this is a 45-degree angle in the fourth quadrant. Okay, so this, for sine inverse, you cannot go all the way around here. These two areas are restricted, so you have to go backwards from 0. You go backwards here to this point right here, okay? And that's negative 45 degrees. Okay, so that is your answer. What was in? Let's look at this again. For a sine inverse or a cosine in any inverse, the in is the ratio, the out is the angle. So what do we have here? We had a ratio, and what are we getting out of that? We are saying that, let me draw it up here a little bit smaller. We are drawing the sine inverse of negative root 2 over 2 is equal to negative 45 degrees. Negative 45 degrees. So if these two things are equal to each other, that means I can substitute this piece with this piece right here, negative 45 degrees. So now I have a new problem up here. I have the cosine here. For this part right here, I'm going to substitute out negative 45 degrees. So let me rewrite that, excuse me. Let me write that problem now again. So we're going to have, instead of the cosine of the sine inverse of negative 1 over root 2 or root 2 over 2, this thing, this piece right here is equal to negative 45 degrees. So I'm going to rewrite the problem to cosine of negative 45 degrees. And now all you're doing is finding, look again, in is angle, out should be a ratio, but this time you want the cosine ratio, okay? Here we had a sine ratio of opposite over hypotenuse. Again, do not be confused with the ins and the outs. So here sine inverse, in is ratio, out is angle. Now we have a cosine, in is angle, out is the cosine ratio, which should be adjacent over hypotenuse, or x over r, which equals, also now looking at negative 45 degree angle, which you have right up here already. What is the cosine now? Take a look at this. Here is the adjacent. Here is the hypotenuse. So now you have a positive cosine ratio in the fourth quadrant there. Okay, now this is your problem. Pretend like you didn't do any of the other stuff before. Be like a machine about this, okay? So let's try this again. Let's try this over here. I could have done the easy one here first. Okay, so first we're going to do the sine, and this should be inverse. So working the inside of the parentheses, so root 2 over 2 is the same as 1 over root 2. So draw yourself a circle. Okay, so in is the ratio, out is the angle. So we want to know the angle where the sine of this ratio, and the ratio for sine is opposite over hypotenuse, is what angle. So again, sine inverse is restricted to quadrants 1 and quadrant 4. Okay, positive rotation this direction, negative there. These are positive ratios. These are negative ratios. Your ratio here is positive. Okay, so we're going to draw our triangle in here in the positive ratio quadrant. Here, opposite is 1. Hypotenuse is root 2. And we want to know this angle right here. This is the theta that we're talking about, this angle right here. And you should recognize it as being 45 degrees. So 1 root 2, special right triangle. Okay, so your angle answer for this will be positive 45 degrees. So now we're going to rewrite this problem. Let me go down here, rewrite it. So you had the cosine of the sine inverse of positive root 2 over 2, or 1 over root 2. This whole thing right here, this whole thing was equal to positive 45 degrees. So if these two things are equal, that means I can substitute this out with this other answer here. So now our problem is the cosine of 45 degrees. Okay, so it's a new world now. Now we have regular cosine. The cosine of an angle equals a ratio. What is the ratio for 45 degrees? We can actually go back up to the same triangle. Doesn't always happen that way. Sometimes it's in a different quadrant. Okay, so we can go back up here. What is the cosine for this? Adjacent over hypotenuse. So that is our ratio answer. Positive 1 over root 2. When you rationalize it, you're going to get root 2 over 2. And that's the answer to your whole problem, okay? We just simplified the input right here. We simplified this input. We got an answer of 45 degrees. So now it becomes a cosine of 45 degrees. What is the answer to that? Root 2 over 2. Okay, that's the answer. All right, let's work some more. Let's just practice these. Here, let's try this one. Let's switch those sine and cosines around. I'm going to do a part 2 of this so you can see a little more complicated problems. These are just real simple ones right now. So again, we're going to work the inside here. So we want to know the cosine inverse of root 2 over 2 is equal to something. So we're going to get a nice clean answer. So then that becomes the sine of whatever that answer is there. So again, drawing the unit circle. Okay. So this is cosine inverse. So in is the ratio, out is the angle. So you have a positive ratio, and cosine inverse is restricted to quadrants 1 and 2. So everything here is a positive rotation from 0. And here are where the positive cosine ratios are, and here's where the negative cosine ratios are. Quadrant 1, x and y are both positive. So draw, since this is a positive ratio, we're drawing our triangle in here. This is the same as root 2 over 2, as we've said before, is the same thing as 1 over root 2. Okay, so cosine ratio adjacent over hypotenuse, or x over r. Okay, so the adjacent is 1. The hypotenuse is root 2. And this is the angle here. So hopefully you recognize this is a 45-degree angle. It's a 1, 1, root 2. You got to know your special rights really well. So let's rewrite this now. Now we know that the cosine inverse, I hope I wrote inverse on there because I was messing. Yes, cosine inverse of 1, positive 1 over root 2. Okay, in is ratio, out is angle. What is that angle? That angle right there is 45 degrees. Okay, since they are equal, I'm going to switch out this with this. Now the problem becomes the sine of, again, I'm switching this out with positive 45 degrees. Now the problem becomes the sine of 45 degrees. Okay, switching gears now. This is why I keep doing that. Now for regular sine, cosine, and tangent, the in is the angle, the out is the ratio. And you know what that ratio is by now. It is square root of 2 over 2 after it's been rationalized, right? Here, opposite over hypotenuse, 1 over root 2, positive, right? Okay, let's try one more here. And then we'll switch to a second video where I'll have a little bit more mixing up going on here, okay? So again, we're going to work the inside. So let's work that out. The cosine of negative, let's just go ahead and write it like this, negative 1 over root 2. We're working the inside of the parentheses. So we know that this is the ratio for an inverse, cosine inverse. That should be, that's cosine inverse. So the input for a cosine or any inverse is the ratio. The output is going to be the angle. Draw yourself your unit circle. Okay. Cosine inverse is restricted to quadrants 1 and 2. Here are where the positive ratio goes. Here are where the negative ratios go. Remember, we have to restrict to make that function 1 to 1 in order to have an inverse. So that's where it's allowed to be. It should never be down here for cosine inverse. Okay. Here's a ratio. So again, all the ratios hold. If you've got a ratio there, this, and you've got the cosine inverse in front, that means this part is the adjacent part and this part is the hypotenuse part. So it's negative. So let's go ahead and draw it where the negative ratios would go. So adjacent is -1 and hypotenuse is square root of 2. So now you are looking for this angle right here. Hopefully you realize that this is second quadrant. So in second quadrant, y's are positive, x's are negative. And hopefully you also realize that that special angle there is 45 degrees. So starting at 0 degrees, going to this one right here, where your 45-degree triangle is in the second quadrant, that would give you 135 degrees. Okay, so in is the ratio, out is the angle. So now I can get rid of this right here. It is not, I can substitute it out with this answer right here because they are equal. So I'm switching out this for this one over here. So let's rewrite the problem. So now you have the sine of 135 degrees is equal to something. Again, in is now, because it's a regular sine, it's not an inverse, in is now angle, out is now ratio. Got to be a machinery with this, okay? So what do you have to do? You just go to 135 degrees, which you have right here. And what is the sine here? Opposite over hypotenuse. The sine is going to be positive 1 over the square root of 2, which when you rationalize it will equal square root of 2 over 2. And that is your answer. Okay,